Welcome to another PV Magazine webinar. This is Ann Fisher of PV Magazine USA. Today's show is all about how to reduce levelized cost of energy and long-term O&M costs in utility scale installations. With nearly 12.5 gigawatts of new utility scale PV that came online last year and even more forecast in the future, it's more important than ever to maximize output while minimizing capital and operating costs of solar power plants that are moving us toward a clean energy future. Single-axis trackers are now predominant in utility scale installations and have been found to increase production by up to 20%. However, there's more that can be done. In this PV Magazine webinar, Nextracker and Shoals Technologies will explore their collaboration on Shoals' new north-south BLA, with the trunk bus running parallel to the torque tube, optimized for use with Nextracker's north-south NX Horizon. This preserves the open road design of the tracker system and enabling equipment to traverse the rows unencumbered. Let me introduce today's speakers. John Haas is Chief Product Officer at Shoals Technologies Group, and he'll show us how to simplify an EBOS installation to unlock ongoing solar field O&M savings. Greg Beardsworth is Senior Director of Product Marketing at Nextracker, and he'll explain utility scale solar best practices that lead to lower cost of energy. We'll get right into these topics in just a moment, but first a couple of housekeeping points. We are, of course, broadcasting live today, so please do send in your questions for all of today's speakers using the questions function on Big Marker, our webinar platform. We'll try to get through as many of your questions as we can in the discussion portion after the presentation. One question I'll quickly answer now is that yes, we are recording this and slides from today's program will be available afterward. These will be mailed out to all who registered shortly after we wrap up today. And you can listen back to this webinar at your leisure at pvmagazine.com/webinars. Here you can listen back to all of our past webinars and have a look at what we have coming up. Lots of great webinars on the way this month, so please do check those out. And now let me hand it over to Greg and John, who will guide us through reducing costs in utility scale installations.
Hi, folks. Good morning, good evening across the world. My name is Greg Beardsworth, and I'm responsible for product marketing here at Nextracker. I've been with the company since 2015, and I've actually been in utility scale solar since 2008. And before we get into the content, I just want to highlight the amazing progress we've all collectively made as an industry. I never would have imagined in my wildest dreams where utility scale solar could have gotten to and has gotten to back when in the early days for me in 2008. So really just coming to this from the point of view of all the progress before and taking everything we're doing to the next level with a focus on LCOE. That's what we're all about, I think, as an industry, and that's what we're definitely about here at Nextracker. So with no further ado, a brief intro to our product portfolio. So we have a suite of solar tracker platforms as well as value-added software to help our customers get the most out of their project sites. With NX Horizon, our flagship product, this is a self-powered independent row tracker. We've now eclipsed 70 gigawatts of experience with this product, unbelievable. And of course, it's adaptable to nearly any solar panel. NX Horizon XTR, this is our terrain following configuration in the newest addition to our product family. And this is a solution to address undulating and challenging terrain project sites, of which we're seeing more and more, of course. Moving over to software and controls, of course, True Capture, I think many folks are probably familiar with this. This is our energy optimization solution, which consists of two pieces. Piece one is adapting to east-west terrain variation in avoiding terrain losses that can come from that. And part two is capturing more energy in diffuse conditions. And then lastly, NX Navigator, this is our operational interface for the entire solar project. It includes functionality around monitoring, around preparing and responding to severe weather when and if that occurs, and also cleaning and mowing. We have modes in Navigator to make that easier, and that is, of course, salient to this webinar. We'll go to the next slide. I just wanted to highlight some of our core technology that's built into our products by design. So number one, Nextracker was first to the industry with a mechanically balanced architecture, specifically optimized for independent rows. We were also first with a self-grounding structure, needing no separate ground bond connectors, wires, etc. And really, we built this company and this product line around scaling up a reliable, long-life, self-powered control system, which builds in data, builds in communications, and an integrated UPS on every row. That's really important. It enables most or much of what we do. And then leveraging all of that is all of the smart software we've developed. And this is how we tie the pieces together, build solutions such as TrueCapture, NX Navigator, and all kinds of things to come. And last point, bringing this terrain following XTR solution to market has been really important for us as solar grows, and as it grows into places that aren't as easy and straightforward to build upon as the desert Southwest has historically been in the early days. And really, there are three key things about terrain following I'd like to briefly stress. Number one, there's a CapEx benefit on avoiding or reducing grading, and also shortening foundation piles. There's a huge risk advantage to terrain following in construction schedules. Grading can be hard to predict. It can suffer delays, and so doing less or none of grading is big. And also on risk, avoiding erosion down the road. The less soil you disturb, the more native ground cover you keep in place, the better. And lastly, environmental impact. We're here to generate clean, carbon-free energy, and tearing up all the land to do it doesn't quite sit well with many of us, and certainly local folks and local permitting authorities. So that introduces Nextracker and what we've been up to. And with that, I'd like to hand it over to John.
Thank you, Greg. Much appreciated. And thank you, ladies and gentlemen, for joining us today. And it sounds like we've got participants from pretty much all over the globe, which is pretty crazy. So as Greg said, good morning, good night, good afternoon. My name is John Hass. I'm the Chief Product Officer for Shoals Technologies. Similar to Greg, I've also been involved in the renewable energy space since 2008, and have spent the entirety of my time in this electrical balance of system subsector with this product sets. It's been an interesting, 15 years, watching the industry just drive change as we seek innovation, as we continue to push boundaries with voltages, module powers, et cetera. And we're excited to support Nextracker with the development of a solution set that really supports their open row tracker architecture. As we talked about, many people know Shoals, but just in case you don't, Shoals really develops and markets the electrical balance of system solutions that perform the collection of the DC power from the modules. We also have solutions in the AC world, but the majority of our products are on the DC side. These turnkey solution sets are comprised of a variety of specific components, some of which are shown here. Junction boxes, we do make OEM junction boxes for a variety of panel manufacturers. The cable harnesses that integrate inline fusing, the main BLA trunk cable that is part of the discussion today, certainly, and that allows us to transition from copper string wiring to aluminum as soon as possible, reducing overall cost. The BLA systems, then go to the load break disconnects in this case, and sometimes combiner boxes depending on the product architecture. Not typically used with BLA, but we support those as well. The cable harnesses are connected to the BLA at mold drops, and it's a little bit challenging to see there next to the inline fuse, and we'll see some more detail later on. We offer proprietary structural wire management clips and messenger wire hangers as well in support of all that. And at the end of the day, our goal is to offer an entire solution set for these specific functions, so our customers really have one place they need to go for everything they need in this DC collection system. Next slide. In the typical home run system that we're all familiar with, I'm sure, this team on site often has to follow the 6 steps that you see in the images above. Somebody's pulling that string wire out, measuring it, cutting it to length, measuring the strip length, doing correct stripping, then crimping, then inspecting, and finally installing connectors on each wire and then to the system. The BLA system is intended as a superior way of doing this when you compare it to pulling all this wire in the field. Next slide. So BLA itself, what is BLA? It comes as an acronym for Big Lead Assembly, and it really replaces, as we talked about, the first 5 steps in the previous slide, because it's a turnkey trunk bus. It's manufactured in a controlled factory setting with calibrated equipment, and it's put through rigorous testing before shipping to the field. Whether it's the mold drop that you see kind of there sitting in the water, or any inline fuse, crosses or tees, anything that is an overmolded component is put through a wet high pot test that guarantees a complete IP68 seal. The UL 9703 standard for which our products are evaluated requires a pass-fail for leakage current during the high pot test of 10 microamps. Our internal standard is 0.5 microamperes. And so we've set our limit 95% lower than the UL 9703 standard, so that when you get the product delivered to the field, it is a completely sealed system. Next slide. So the end result, and specifically talking about the BLA, is this DC collection system that eliminates all but 2 field terminations in the field. The last 2 terminations need to be made at the load break disconnect, but everything else is done turnkey. That reduces the field labor in several ways. Your termination, which requires a master or certified electrician, is really limited to those last 2 connections. Everything else can be done by lower level electrical staff as they run these wires out into the system. Inspection is also faster because you know that the entire assembly has already been tested and certified at the factory. Next. From a deployment standpoint, this is a fun slide. So far, we've delivered over 22 million feet of the BLA cable itself solutions, not even including the overmolded string or cable harnesses that go with it. And that alone is enough to go from New York to California and back. So we've got a tremendous amount of installed base out in the market. So we've got solid data on long-term performance. Next.
Yeah, well, thanks a lot for all that, John. And when we look back in 5 years from now and see what that slide looks like, how many more trips across the country with the scale up of solar, I think we're all going to be amazed. So really cool stat there. So I'd like to circle back on the tracker side to the value of independent rows in a bit more detail. So tracker technology really got its footing about 20 years ago, give or take. And at that time, really the only thing that made sense or was practical was to use existing PLCs and existing motor drives out of the industrial sector in general. And this equipment, was never specifically designed around solar, more multi-purpose. And as those items were fairly expensive at that time, linking many rows together was common sense, and it made economic sense to do. And so you see on the left, there's different ways, of course, of doing linked row systems, but we characterize it, anywhere between 10 and 20 rows linked together on a mechanical linkage to a common drive and control system. Now, really, how Nextracker built our business and continues to grow is around the notion and what we believe we've proven, that there's a better way, and that self-powered independent rows are a path to lower LCOE. And this is core Nextracker DNA. A couple benefits I want to highlight specifically. On the energy generation side, having control of each row individually, that enables us to do things like true capture and adapt to terrain, adapt to weather conditions. And there's real energy yield benefits that come from that. We also, by virtue of no linkages, more easily extend our tracker operational range. So plus or minus 60 degrees or 120-degree range of motion is standard with Nextracker. And also it frees and clears some of the mechanical structure on the back side. So there are less objects obstructing light on the back. And as you know, the vast majority of the crystalline market is now bifacial pretty much by default. There's meaningful energy gains there as well. Moving on to installation and operations. I touched on this briefly before. Every row has an integrated UPS as well as a solar powered powering source. And that means no auxiliary wiring, and it means resilience in the case of a utility outage. There's typically correlation between severe weather and the utility going down. So not having to rely on that to do any number of different defensive stowing strategies is really important. Every row gets monitoring and data by default with our control gear. And again, supporting some of the smart things we're able to do on things like TrueCapture and Navigator. And lastly, but certainly not least, and most salient to the rest of this conversation, is open site access. You can see pretty clearly in those diagrams, long north-south rows with nothing blocking, people, machines, equipment, animals moving through the site. And there's real value there when you think about LCOE and long-term operations and maintenance. So segueing into that, I promised we would talk about LCOE, and in the context of this webinar, we're honing in mostly about operating costs, OpEx, and where open and independent rows influence that. So this is actually really interesting. This may not be widely understood, but per an NREL study and an O&M cost model that they built, in which they surveyed a pretty long list of actual solar projects, they concluded that very specifically panel cleaning and vegetation management or mowing is the second biggest stack of costs in the overall O&M Pareto, second only to inverter maintenance. And it comprises about 20% of the total O&M budget for a project. And if you contrast that, I've also highlighted, where tracker maintenance itself falls. That's item 5 or 6 on the list, and it's less than a third spent on maintaining the tracker. So it gives a clear indication as to where to focus and how important it is for all of us in the value chain to do things that make panel cleaning and vegetation management simpler and easier. A couple images, you can see mowing taking place on a Nextracker system and panel cleaning taking place on a Nextracker system. And conversations I've had with developers, owners, EPCs, this rings true. There are other studies out there, of course, as well, but this NREL one is great, and I'd refer folks to take a look in their spare time. So let's look a little bit deeper about how the tracker architecture affects these O&M costs. I'm going to advance. There we go. As you can see here, we have a cartoon depiction of a linked row system with that drive linkage I described earlier running east-west. In the point, or typically how those are architected, is they run down the center, roughly the midpoint of each tracker row in the east-west direction. And they, of course, create an obstruction. They're typically at a height and they're big enough where you can't drive under them, you can't drive over them. Certainly people could cross them typically, but machines can't. And so when you're dealing with a linked row tracker, running DC wiring down the center, roughly in the same place as the drive linkage, makes a lot of sense, as there's already an obstruction there. So I'm going to hand it back to John, who's going to talk a little bit more about how these things come together in detail and how a north-south solution can make sense.
Like, if you will, as he said, kind of shows that BLA being supported along the drive line with the load break disconnect box in the heart of it. Next click. Actually, there you go. Back up right there. There you go. the intent there is just to show that, in a system where we're going to run the BLA north-south, that, you see that it completely allows for the open access between the rows. And that's just the intent of just kind of, here's the graphic below the cartoon clips, just to show exactly how those are being supported. Next one. And so next slide. And so, more specifically, we're excited to announce having worked with Nextracker in partnership to really come up with a BLA system that's intended to support their open row architecture. And we have a short video about this. Thank you very much. To the next one. So just taking a quick step back in terms of just the overview of different DC collection wiring approaches. We're really making the assertion that a factory-produced BLA system is a significant improvement over the traditional home run systems as a function of going from field-assembled wiring to factory-made harnesses. And then if we look at the east-west DC collection versus north-south collection, how do we maintain open rows with that factory solution? So as you kind of go on this graphic from left to right and from top to bottom, you get to the point where at the bottom right, a factory-made solution set that preserves the open row architecture that Nextracker really provides, really derives the best low-cost LCOE for the system. Next slide, please.
Great. Yeah, thanks for that walkthrough, John. And I think a lot of folks are probably asking themselves, and we've been asking ourselves and our customers for quite some time, so exactly how much is this worth? What is the value of open rows when it comes to maintenance? So we're going to divide this into two pieces. Piece one is mowing, and a little bit about background before I talk to some of these numbers. So over the past couple of years, Nextracker has built and refined an economic cost model, leveraging feedback from EPCs, system operators, and some existing literature. And we use that to compare a number of different scenarios. It's configurable to different cases. And the numbers we're talking about here is a 100 megawatt reference project case. And assuming we do mowing 4 times a year and also cleaning 4 times a year. And so highlighting kind of the compare contrast here, you can see on the left-hand side the serpentine kind of route that a mower might need to traverse when there are obstructions down the middle of each row. So we mapped this out, and on this 100 megawatt reference case, every year, whoever is responsible for maintaining this site is going to drive or move their mowers about 990 miles and take about 1,300 hours to keep that site free and clear of excess vegetation. And we've estimated that's going to cost about $185,000 annually. And of course, play that tape forward year over year. By contrast, open rows, and you can see a great visual there of a really neat set of mowing equipment. This actually came from a company called Fisher, and they make some interesting mowers. These particular projects are being maintained in Australia. And you can see very clearly a powerful visual about how that whole equipment set can move freely north-south through the row. And so taking this, what we call single pass mowing approach, the mileage get cut by about 55%. So we're now sub 500 miles for the year. In about 600 hours for the year, and down to about $84,000 of estimated cost. So we like to, of course, try to make trade-offs between capital cost and operations cost or energy. And a reasonable way to do that is to take a simple net present value of the long-term costs incurred of this mowing operation. And the savings in this case, the difference between blocked and open on a net present value basis is about $1.4 million. This is 100 megawatts, so that's 1.4 cents a watt DC. We go and look at panel cleaning. The baseline with a blocked row is actually, we've modeled to be identical with the same turnarounds and the same mileage. Now the cost is a little bit different. Feedback we have is that the equipment rates of typical mechanized cleaning equipment is a little bit higher than that of mowing. So we came up with a figure around $240K annually for this 100 megawatt project. But the benefit of independent and open rows on cleaning is actually a little more. One of the things we offer and users can trigger via NX Navigator is a cleaning mode where we actually go every other row, or all rows face each other, basically alternating. And with the right equipment, that enables kind of double pass or half pass mowing where every other row is traversed with a double-sided brush. Assuming that's performed, then the savings are about 73%, and the mileage and the time drops accordingly, and the total cost about $65K a year. And this comes up with about $2.4 million of lifetime NPV savings on the cleaning front. So these are important operations. Fundamentals of solar is, a lot of acres, and simply dealing with nature and the site and the topography and the vegetation, and then the dust and soiling effects on panels. It's a huge aspect to running these projects over their life. So I think these figures really paint a picture around that, and hopefully folks found that informative. I'm going to hand it back over to John to talk a little bit more on the CapEx side, specifically looking at other aspects of DC wiring and site design that maybe isn't immediately obvious to some.
We should comment that Shoals is somewhat agnostic to clients' preferred architecture, and our intent is to demonstrate that the north-south open row system results in some interesting savings that are unique. And one of those things is really looking at the DC feeders and roads that are required when you have a linked row tracker. You can see in this image that we have to have a road access between every single tracker in the east-west direction, the roads, that is, and this results in DC feeders coming to a somewhat centralized inverter skid that yield, in this case, a little over 15,000 feet of feeders, over 800 feet of trenching, and the roads taking up a decent percentage of the ground available. Please click. And then you look at that, compare that to the version with north-south, where we're able to limit the DC feeders significantly because they're really coming off the south end of the rows in this particular case, for example. It's a significant reduction in the DC feeder lengths. There's a significant reduction in the trenching, and we've basically got a third of the requirement for road access because we have open access north-south through the trackers. Next slide. And Greg's going to take this into what is the kind of the net effect in terms of we've looked at this and modeled this.
Yeah, great. Thanks so much, John. So let's put together the overall economic picture here. In this table, we've translated the OpEx costs associated with cleaning and maintenance into a $ per watt equivalent, as I described earlier, so that they can be kind of put on equal footing to some of the capital costs. And similarly, we took some energy benefits and did the same and took a net present value of the, at typical PPA rates, what that's worth. This is our way of trying to tell an LCOE story in simple terms, where we can look at everything in terms of real dollars per watt spent on CapEx or $ per watt equivalent of long-term maintenance or energy yield. Tying it all together, really, this is a linked row system with east-west wiring, as we've talked before, as compared to an NX Horizon independent row system with north-south BLA wiring. Calculating out the dollar impact of the site design, the DC feeder lengths and the roads John just talked about, the 65% reduction in roads, the 56% reduction in DC feeder conductor, and the 26% reduction in trenching, we get a sum there, half a penny, 0.6 cent pennies, 0.1 pennies, just north of a penny a watt right there on the capital side. And then summarizing the mowing and panel washing benefits, there's 1.4 cents and 2.4 cents. So that's 5 cents a watt of LCOE style or dollar per watt equivalent savings in going with this architecture. We acknowledge not all sites are the same, of course, and the economic picture will be different. But this is real important, and really urge folks to think about the long-term picture and the LCOE picture when making design decisions. Also, I'd be remiss if I didn't point out on the energy yield side, specific to Nextracker, the combined benefits we typically see between range of motion, better bifacial gains, and true capture relative to a traditional linked row system is typically at minimum 2.5%. And I'm being a little generous there. That's kind of on the low end. But you add those in as well, your results may vary, of course, depending on the financial structure of the project. But 2.5% ballpark is kind of 2.5 cents a watt equivalent value. So, that brings 3/4 of a penny, 7.5 pennies a watt. Messed up the decimal point there. Bear with me. From this is our last prepared slide together. I hope it's been informative, and really we're here to educate, inform, and hopefully change the conversation from, there's a trap sometimes to be in a pure capex mindset. We certainly understand that, and not trying to minimize that, but we encourage developers, EPCs, independent engineers, others who are following along here with this storyline to really think about LCOE, and that means CapEx, operating costs, and energy. Think about all those things together when you're making design decisions on the front end and technology selection decisions on the front end. And at the end of the day, speaking for Nextracker, and also I'm sure for Shoals, we look forward to helping you on your projects. So
very much so.
John, any last remarks for you? I think we go into Q&A next.
Thank you very much. The intent here, and I think Greg hit the nail on the head in terms of we've put a lot of time and effort in discussions with the EPCs and owners on the O&M side, and really looking at that long-term big picture for performance of the system. And we're glad to have the opportunity to support Nextracker with this particular architecture.
Fantastic. We're thrilled you guys have brought it to market, and look forward to another decade of massive solar growth. So thank you.
Sure seems like it's going to be that way, which would be wonderful. So I think we shifted to the Q&A portion. I think Ann takes over for us.
Okay, well, thank you, John and Greg. We have several questions here. For starters, what slope terrain can the terrain following tracker tolerate?
Hey, Ann, I think you may have asked a question. I think the first bit was cut off. Could you do that again?
Okay, what slope terrain can the terrain following tracker tolerate?
Got it. Great question. So the particular tolerances, we work that out on a project-by-project basis. What we have found is that the undulating tolerance that Nextracker provides and configures is in many cases able to avoid grading altogether. And we've, in more extreme cases, where it may not be 100% eliminated, we've seen savings as high as 80 or 90%.
Okay. Next question, does the messenger wire act as an earth ground wire as well? And what is the span for clips on the messenger cable?
So the short answer is yes, a messenger wire system can also serve as a ground in the support function. The span on clips is often dictated by local code. We typically see support required at least every 3 feet. And there's some sites that push to 2 feet. I've also seen other sites where the messenger wire hangers are even farther. It's really dictated by the code and your engineer of record.
Okay, how do you keep up with BLA supply to meet the growing market demand of 40%?
Yeah, this has been a fun one. I mean, Shoals has definitely stepped up to the plate in the supply chain world, working with really, key suppliers from multiple regions. We try very hard not to allow any one supplier to be the huge majority of our supply demand, just because we want to mitigate the risk. And so, at the end of the day, it's working with a variety of people. All of their wire goes through extensive qualification testing as we look at new suppliers, et cetera. But we really need to spread it out because there is just a crazy amount of linear feet of wire.
Okay, how do the integrated UPS systems perform in cold northern climates?
Yeah, great question. So we have extensive tracker experience in northern places that see severe snow and low temperatures. We use a number of protective measures on our control system to address that. During the day, we run heaters. During the night, we carefully manage the battery. And we have a range of different PV panel wattages that we apply depending on site condition to address the sometimes occurrence of very low irradiance during snowfall or cloudy days in those northern latitude sites. So relative to where we started years back, our ability to deploy independent row self-powered trackers in severe cold has expanded dramatically as we've got more and more experience and built out these different protective measures. I'll also call out, we have snow shed functionality built in with NX Navigator, or I should say available with NX Navigator, giving operators the ability to configure a whole range of snow mitigation measures, taking advantage of what the trackers do best, which is to move and reposition themselves. So I, of course, won't get into any proprietary details about sizing and exactly how we engineer these, but rest assured, we have a whole package of environmental hardening associated with snow, cold weather, and low irradiance.
Okay, so now turning to agrivoltaics, what are utility scale agrivoltaic projects that you can reference using the Nextracker technologies?
Yeah, well, that's an interesting question. You think about the long haul, the years ahead with this industry and community acceptance, land that's good and close to transmission may be employed for other purposes. And ultimately, we all have to get along and we've got to use the land in the way that makes the most sense. So agri-PV is a hot topic and one that I expect will be relevant be more relevant for the years ahead. We have a number of pilot projects that we're working on. I won't go into any more detail than that, but a number of pilot projects related to agri-PV. There is, of course, a combined economic question about crop yields and agriculture use versus energy use. Frankly, I think it's going to take time for the business model for those two things to coexist together to really get figured out and determine, what is the best type of crop that works with that in different locations. So we're very excited to see where this evolves. We're participating in that space with some technology and R&D investment in some of our facilities around the globe, as well as partner facilities with customers. I think the roadmap will evolve over time, and it's probably going to be different needs in different places. So That's really all I can say at this point, but certainly opportunity to co-locate trackers in agriculture. And we're excited to be a part of that picture.
Okay, so back to technical details. What's the minimum distance from the bottom of the torque tube to the messenger wire?
Ooh, that's a good question. I don't know that off the top of my head. I have to get some information from the engineers of record. Again, some of these little details fall to the region or state that you're deploying in. My apologies, I don't know that one.
Okay, another is, when will the NX Horizon and Shoals North-South BLA be made available in the Canadian market, or is it ready now?
I can speak on the BLA side of the equation. We are in our final weeks of our certification to the new and updated Canadian standards. They are interesting and challenging. I don't have a specific date on availability, but I know that we're awfully close on our side.
Yeah, and on the tracker side, we're doing business now in Canada. We've done business in Canada, a bunch of large projects operating and coming online there in the country, and we fully expect to see the combination of Shoals North-South technology with Nextracker there. We didn't talk about it in the presentation, but thinking about snow clearing and access when there's snow accumulation, another reason to try to keep your rows unobstructed from my point of view. I'm sure we'll learn more about that as those projects get operational experience. But anyway, fully loaded and doing business now in Canada on our side.
Okay. Does the East-West BLA require more underground work?
No, as we showed in the one slide, the DC trenching, there are techniques to mitigate some of that DC trenching requirement, but we do see clients really taking things underground kind of as quickly as possible from exposure standpoint. However, there are techniques to bring it to central trenches and things like that. So in the diagram we showed, yes, there's more trenching and therefore direct burial wire happening or transitions to underground compared to the longer rows where we only have to do that at the very end.
Yeah,
okay.
I'll just chime in here briefly. I've had a number of conversations with some of our top EPCs about this topic. And of course, there's a wide range in different architectures and block layouts of where wiring is run. The example we used in this webinar is, I think, a good sort of typical or middle of the road case. In it, I'll just remind and highlight that there was a trenching reduction of about 26%. Most of the benefit of going north-south was in the DC feeder conductor itself. So I would expect those numbers to move around, obviously, depending on how the EPC might be doing it. And certainly, I don't think we can claim that what we showed is necessarily the absolute minimum trenching solution. But I think in all cases, you're going to see a benefit of going north-south, which of course has to be factored in along with all the other considerations. So.
Okay, so another wiring question. How much extra PV wires needed for a 100 megawatt project when putting it along each row?
The interesting thing is in the north-south application, if it's home run wire, you could have a typical block with over 100,000 feet of 8 gauge, 6 gauge, sometimes now 4 gauge, dealing with the voltage drop when you look at the traditional home wires. In a north-south BLA solution, now we're aggregating those into a singular wire, but we do end up with more BLA wire north-south clearly than east-west. You've got to run 750 feet if you're looking at kind of a 3-tracker tall system, but it is it's a similar amount of copper at the end of the day compared to traditional home wiring, but you've reduced it down to a single rollout part versus pulling individual wires.
Okay. Another cabling question. Why don't you run the cable underground through the middle of the rows to reduce the length of cable needed? And how do you run the cable from the combiner box to the inverter in your proposed solution?
So first part of the question is why not go underground versus so in the Nextracker north-south unobstructed rows, just go underground? I may misunderstand that part of the question, but the second part of that question was from the load break disconnects and or combiner boxes in the case of a home run system. The very bottom of that trenching image showed just a single east-west trench that would then bring the DC feeders to the inverter skid.
Okay, the first part of the question was why don't you run the cable underground through the middle of the rows to reduce the length of cable needed?
Yeah, I interpret that to mean on an east-west collection case. And, you know, my guess here, this is a little outside my direct expertise, and John chime in, but, you know, my guess would be, number one, that would be an enormous amount of trenching relative to other designs. And number two, from a construction sequence point of view, you know, having a whole bunch of east-west trenches running through each tracker block would probably cause issues in, you know, either building the trackers or installing panels or getting other things through the site. So I think what we typically see is a focus on getting the trenches shored into the north-south in the case of east-west collection, and getting the trenching shored and running east-west along the bottom or the top in the case of north-south collection. That's, if I understood the question right, I guess that's what I can
or
add.
if in the north-south architect in the Nextracker architecture, perhaps this individual is asking why not just bury, you know, larger cable between the two trackers rather than having to go on each tracker, and that really would then go back to that trenching question. It's just, you know, north-south trenches as you're trying to drive piles and things like that, and your construction sequence might make that difficult. Not impossible, but difficult, and that's a lot of trenching.
Okay, in a similar vein, how does the underground work compare between east-west and north-south BLA?
That kind of went back to the one slide we showed where we showed the east-west coming into some north-south trenches to get to the inverter block. When you transition underground, you often have to look at your wire sizing because the free air rating for the wire is a higher current than the underground portion. So if you can limit the amount of time you're underground, you can reduce the amount of time where you need to oversize the wire because of the rating. So that was where I think we had 5,370 feet of DC, you know, feeder wire, which a lot of that's underground then, versus was 1,286 or something like that at the bottom of the other slide.
Yeah, those numbers were about 15,000 feet of
That's right.
DC feeder conductor. This would be the big aluminum stuff on the east-west case versus about 6,000 feet in the east-west case.
Or the north-south case, yeah.
Excuse me. Yes, thank you.
Okay, would there be any different BLA space design between east-west or north-south wiring?
Different. I'm sorry, repeat the question.
Would there be any different BLA space design between east-west or north-south wiring?
Space design.
Maybe they're talking about the span between the hangars or something, John? I'm kind of guessing what that might mean.
Is that individual available to elaborate their question? Or perhaps we can come back to that one if they submit.
Yeah, let's do that. Can the north-south BLA attach to the tracker piles, or does it need to be on its own?
We use the tracker piles to hold the brackets that support the messenger wire. So absolutely, it is connected to the tracker piles, not to the torque tube.
Okay. Does the NT software do anything to compensate for windy locations to avoid lost production?
Yeah, absolutely. That's a great question. We've had quite the string of wiring questions and back to tracker, so happy to jump in on that. So there's a number of wind protection strategies that we use. There's a layer of automated wind stow functionality built in. And on top of that, there are additional wind protection measures such as hurricane stow, where the system operator can make choices about how they want to configure the system. Nextracker uses as standard a network of anemometers, kind of ring fencing the solar project. And with our software and some proprietary algorithms, we're able to kind of differentiate between wind events that need response, that truly need response, versus those that do not. And with that, combined with our individual row level controls and communication, and the rapid repositioning capability with the balanced rows and in the technology we use, we're able to cut off sort of the unnecessary, if you will, stow time, at the front end or at the back end, in clearing the stow command after the event has passed. So without getting into too much engineering detail or exactly how we accomplish that, yes, absolutely. Being smart about how we stow and getting into position when it's necessary for the safety of the equipment and the personnel, but avoiding any nuisance stowing is part of our core R&D and technology built into our products.
Okay, what portion of the monitoring system is wireless, and what portion of the tracker control system is wireless?
Yeah, great question. So we use wireless to have all the tracker rows talk to a central point of control and monitoring. So we have this unit called the NCU, Network Control Unit. They typically live one on each inverter skid, depending on how the system is built, usually around 2 megawatts, give or take, of tracker rows associated with each NCU. All of those communications are wireless. Those NCUs are then linked together for the entire power plant on the fiber ring that's connecting all the inverters and everything else together. So the vast majority, all of the tracker to other device communications are all wireless. And it's a really neat characteristic of the technology we use, that those communications and commands can be propagated very quickly through the entire array without the drawback of having to run wires to each row, because that would really be a non-starter.
Similarly, in the product slide that we had for Shoals, there was a string current monitoring device, IV curve tracing device, similarly built on a 2.4 gigahertz mesh network. They are parasitically powered from the panel itself, so there's no power wires to run, and everything mesh networks back to a gateway. We typically handle somewhere between 250 to 300 nodes per gateway, so it sounds like it's similar to the gateway, the NCU that the trackers talk to. So it's a similar approach.
Okay, what portion of each of the systems qualifies as Buy American?
For Shoals, it's 100%.
Yeah, so with Nextracker, we have built out an enormous US-based supply chain to complement our global supply chain. I am not personally prepared to answer the exact Buy American clause. I have to unfortunately come back with an answer to that, as I'm just simply not sure. But as we work through IRA and everything else, rest assured, Nextracker has a complete US-based supply chain capability.
Okay, well, we're getting close to the end of time here. So final question is, do you have units in Mexico?
We have trackers deployed in Mexico, absolutely. What was those many projects? What was the biggest at the plant, biggest power plant in the world at the time is one of our marquee projects there, 700 plus megawatts, Villanueva and countless others. Yeah, John, on the Shoals side?
I apologize. I don't know the specific answer to that. I'm sure the answer is yes, but I don't want to misspeak and state that.
Got a couple stumpers in there.
Yeah, it's like, okay, that's a great question.
I got one. You got a couple. Yep.
Yeah, great questions. Well, that's where we'll have to wrap up for today. So thanks to John and Greg for the presentation and for sticking around for the Q&A. And thanks also to everyone at Nextracker and Shoals, and of course to my colleagues here at PV Magazine for putting together another excellent webinar. And finally, thank you to all our viewers for joining us today and to all who submitted. And we really do value your contributions to the discussion. And my apologies again that we can't get to all of your questions. Just a quick reminder that the November issue of PV Magazine Global is out and solar finance is the focus. The edition takes a 360-degree look at this new environment for solar investment and what it means for our industry. There are also plenty more great webinars on the way. On December 1st, together with leaders from U.S. national labs, we'll share data collected on factors and drivers of O&M costs in utility-scale solar and energy storage systems, as well as review ongoing challenges in this space. And on December 8th, we'll be discussing how to protect battery energy storage systems to increase reliability and maximize return on investments. For today, though, that's just about it. Any second now, we'll have a short questionnaire that will pop up on your screen. Just looking for some feedback on today's program, and we really do appreciate if viewers can take just a minute or so to fill that out. Your feedback's really valuable to us, so thanks in advance for that, and we hope to see you at another PV Magazine webinar very soon. For now, it's goodbye from all of us.
Thank you. Thank you.
Thank you.
Bye, all.